Welcome to DevOps and Docker Talk, and I'm your host, Bret Fisher. I'm a Docker captain, a cloud native ambassador, and I create cloud native DevOps content on YouTube, podcasts, and courses, and I hope you find all this useful. This episode is all about AWS Graviton instances and ARM-based servers in the cloud. I'm with my co-host, Nirmal Mehta, this week, and he brought his AWS colleague, Michael Fischer, on the show. Michael is a principal specialist solutions architect focused on efficient compute at AWS. Last year, I was talking with Nirmal about having a show focused exclusively around Graviton instances and the rise of ARM servers in data centers. Graviton is AWS's term for their custom ARM-based EC2 instances. As of today, we now have all major clouds offering an ARM-based option for their server instances, but AWS was first. And way back, at least I think they were first. And way back in 2018, they announced Graviton V1 instance types. And if you recall in 2018, which was only 6 years ago, but a lot has happened because in 2018, we didn't have Apple Silicon MacBooks. We didn't have Raspberry Pi 4s yet. So the average engineer didn't have access to high-end ARM CPUs that were designed for server workloads. Fast forward 6 years now, and AWS is releasing their 4th generation Graviton instances, and they deliver all the CPU, networking, memory, and storage performance that you'd expect from their x86 instances and beyond. So you'll hear me talk about my own experiences using Graviton as well as my clients, and it's no secret that I'm a big fan of ARM-based servers and their price points that AWS gives us. They have been my default EC2 instant type for years now, and I recommend it for all the projects I'm working on with companies. We'll get into the history in this episode of Graviton, how easy it is to build and deploy containers and Kubernetes clusters that have Graviton, or maybe even 2 different platform types in the same cluster, and we'll cover what it takes to build multi-platform images using Docker Build Kit. This is an edited version of our weekly YouTube live show that you can join us and ask our guests questions on Thursdays at 1 p.m. U.S. Eastern at Bret.live. We had multiple demos in this one, including a simple example of building a Java app for both x86 and ARM64 architectures, and how to deploy that workload to a single Kubernetes cluster that has multiple node architectures in it. You can watch the full demos in the live stream recording found in the description. So please enjoy this episode with Michael Fischer of AWS.
Hey, Bret, how are you?
Good.
Let's bring on Michael.
Michael, welcome to the show.
Hey, thanks for having me.
So, Michael, tell us a little bit about how did you get to AWS and why are you focused on efficient compute?
Yeah, I've been working with computer hardware for many, many years at this point. Shows my age a little bit, but I grew up in the 8-bit age. My first computer was a Commodore 64. And then after that, I had an Amiga, and both of them were taken apart and broken and replaced multiple times. And then I started building my own PCs. I sourced my own cases, and I went and searched for motherboards. I sourced my own cards at the time, and even like modems and network cards and stuff like that. Stuff that we take for granted that's being on board on a motherboard today. And I also used alternative hardware very early on. Intel has not been the only player in servers in our recent history. We've had movies that were made with SGI-based instances that were running MIPS CPUs and custom graphics hardware. We've had Spark was powering very large websites like Ticketmaster and eBay for the longest time.
Spark. Those are good days.
Yeah. My first professional workstation was a Spark Station 5. And Linux really only got on the scene I would say it started to be taken seriously for production workloads starting in the late 1990s, early 2000s, because people saw the value in it. And the fact that you could, in fact, run it on increasingly powerful commodity hardware like 32-bit Intel processors, and now 64-bit is the standard everywhere. Not just on server hardware, but all the way down to my phone and my watch. Right. Both of which, by the way, are powered by ARM architecture CPUs today. So one of the things that's super cool about ARM is not only does it scale out, which we'll talk about, but also scales down really tiny as well. And that energy sipping architecture that lets my watch with an OLED display run for 24 hours before it needs a charge It is similar technology that lets us power our servers now with like 60% less energy than they ever could before. That's pretty incredible. So my journey went from building my own PCs to running websites and web services and internet services on Spark and IRIX or Sun SGI DEC Alpha machines. And then finally, once Linux made mainstream, working at big companies like Yahoo and Zendesk, which is where I worked at before I came to AWS. And today, I'm fortunate enough to work for AWS, where I've been helping customers adopt containers. So before I joined the team working on Graviton, I was on the team helping customers adopt AWS container services like ECS and EKS. And I'm a person who loves to skate where the puck is going. And a couple years ago, I recognized that we were going to begin making an ARM64 CPU for AWS Compute mainstream. And I asked to join the team, and they interviewed me and they accepted me. And I've been very proud to work for this team for the last 2.5 years. And one of my favorite things to do is talk to customers. I love it when my calendar is full of customer calls. And I love meeting customers at events like reInvent, at AWS Summits.
So can you give us so your background is supporting these large websites like Yahoo and Zendesk and scaling out those architectures on the cloud. At AWS adoption of containers, can you give us a brief history of what got us to today with Graviton 4? So Graviton 4 means that there was at one point a Graviton 1. And so what's the background with respect to AWS and ARM in the industry?
So one thing that's important to know is that Amazon has been in the hardware business for a very long time. Those of us who are here today in this talk and our guests are interested in AWS in particular, but our investments in hardware go back further than that. The most well-known one, of course, is the Kindle. At the time, there were ebook reading applications for things like, if you had a Palm Pilot or something like, or, small handheld computer or something like that. But there was no inexpensive general device whose sole job was to, allow you to buy books from an online e-store and then read them right there with e-ink and a super bright screen and super lightweight. You could and very robust and well built as well. So we've been in the hardware business for a while. And of course, if you've ever gotten the chance to see inside an Amazon fulfillment center, just chock full of custom robots, controllers, cameras, microphones. If a mouse sneezes in there, you probably, some IoT system is going to detect it, right? And so we're really comfortable working on hardware. And AWS early on, when we started to offer more and more in terms of different services, expanding our portfolio of EC2 instances, customers came to us and, they always want more. They want less expensive. They want more value for their money. They want more security. They want better performance. And at the time, EC2 was built on largely a software virtualization stack known as Xen or XEN. Some of you might be familiar with that. Xen is a software-based hypervisor. Its job is to basically provide both utilize the CPU's own functionality for virtualization, but also has to take care of device virtualization as well. So when you're using a server, you're not just using CPU. Of course, you've got network connections coming in and out. You've got virtualized storage like EBS. And those functions, those hardware virtualization functions at the time were all done in software. And not only that, but Xen itself has a fairly decent footprint in terms of the amount of resources it uses for its own record keeping. So it uses a certain amount of memory. And all of those resources that are used by Xen, they take up a lot of precious space on an instance. And because of the customer demand and because we wanted to be able to offer customers more security and more efficient use of the hardware that we have that powers EC2, we decided to move from software-based virtualization to hardware-based virtualization. And EC2 Nitro was born out of that. EC2 Nitro, if you're not familiar with it, is a custom AWS technology that consists of a card that we call the dongle that plugs into the server chassis. And its job is to provide virtualized networking and storage to every single piece of hardware that we have so that every customer that we have gets more of the instance that they ever got before. And it's also faster because all of that virtualization technology is done in hardware instead of software, or rather it is offloaded to this Nitro daughter card. There are lots of advantages of moving virtualization functions off to a daughter card. Number one is that you can have a completely independent software update lifecycle. If there are patches that need to be done, they can be done on the card without ever touching any customer workloads or causing interruptions for customers. Mm-hmm. Number two, it allows to add new functionality in hardware or software that, for example, cryptographic networking or encrypted networking. So now we offer completely transparent encryption on the wire between instances in a VPC, depending on, as long as they're a relatively new generation. So customers who are concerned about encryption on the wire between their instances in a VPC don't need to worry about that anymore. They can just tick that box and they don't have to run their own TLS encryption anymore for that kind of traffic. And the other thing is it allows us to get network performance that we could never achieve before. Nitro allowed us to accelerate to, we now have instances that can do 100 plus gigabits of network throughput on them at millions of packets per second. We could never do that with Zen, not even close. So overall, the VMs can be made bigger. We can fit more of them on the hardware, and it's near native performance. And on top of that, you get these security functions like encryption. We also have trusted boot capabilities now because every single one of our Nitro cards has a hardware-based encryption key on it. And also, security functions like VPC. A lot of the VPC functionality can be put on the card. So it's at the edge instead of in the center of our networks, which also allows us to scale out better as well. Security group enforcement is a good example of that. When you put an instance in a security group, those rules are actually enforced by the Nitro dongle instead of it being done in software. So what does this have to do with Graviton?
Yeah, I was going to say, awesome. There's this awesome dongle.
Nitro was actually the first step in our Graviton journey. Nitro is powered by an early version of Graviton. The CPU on the Nitro data card is what became the CPU used in our earliest pre-Graviton ARM, general purpose ARM instance called the A1. So we literally took that chip off the daughter card and made A1 instances out of them as an experiment. And we got some customers and we learned a few things. We learned about what it's like for a customer to migrate from x86 to Graviton. We learned what's important in terms of performance, what kind of workloads it could be best suited for. And we took that research and we went back to our labs, which is called Annapurna. And Annapurna produced Graviton 2 and that was in 2019, which was our first general purpose version of Graviton. We called it Graviton 2. And Graviton 2 debuted with 64 CPUs for the largest instance size, which at the time was nearly the same as our largest x86 instances. You could have up to 16 gigabytes of memory per vCPU. So a lot of memory especially on our X2 GD instances. And with Graviton 2, we set out to prove, and I think we did, that you could have a EC2 instance that was as capacious as some of our biggest x86-based instances in terms of CPU core and memory, and also not only performance comparable, but even more scalable than those x86-based instances because of Graviton's unique design. Then 2 years later, we rolled it in 2021, we rolled out Graviton 3, which built upon Graviton 2, was 25% faster, up to 60% more energy efficient than an x86-based instance. Totally mind-blowing. And the first in the industry to use DDR5 memory. And, we're not content to stand still. We have a long roadmap of Graviton. And just in December at reInvent, we announced Graviton 4. Graviton 4, again, 20 to 25% faster than Graviton 3. And it's going to scale out incredibly. The Graviton 3 will have up to 192 CPUs available on an instance with up to 1.5 terabytes of memory per instance. So we've come a long, long way from a chip on a daughter card powering virtualization functions to it actually being the technology of the instance itself, operating at just scales unimaginable for ARM64 before. Sustainable as well.
So thank you for that. I remember seeing, I'm going to have to see if I can find it, but I remember seeing a picture of that pre-Graviton hardware instance for EC2, and they literally took those Nitro cards and they just packed it into a rack server. And that was kind of the initial phase of providing those ARM chips to customers.
I was actually trying to look for one. While y'all were talking, I was trying to see if I could find a picture of the card. And I don't know if any of these are real or not, but there's...
Oh, yeah, that looks pretty legit.
One of the things, before you, real quick, like for those that are listening or watching, if you're not using Graviton, or if you haven't tried an ARM server yet for your workloads, tell us why. Like, I would love to hear from people that are... have either switched to it and they're fans, or have tried it and it didn't work for them for some reason. I actually haven't ever seen that, but I'm sure there's scenarios where it's not as good as their previous setup. I don't know. I've been a huge fan since Graviton 2. I kind of was doing loose math for a couple of clients when, by the way, Graviton, it came out in 2018. Like, we're not talking about decades of evolution here. We're talking about the last 6 years that you all been able to have 4. You're almost on a pace of like Apple releasing their M silicon and the A chips. It's like every other year is about where you're at, I feel like, with a new release. And it's this crazy, I was looking for graphics, and I don't know if we have any, like, sort of showing that the growth of like the number of CPUs, the amount of memory addressable, the speed of the memory, obviously just like all the other CPUs that come out are of AMD and Intel. But it just strikes me as like, by the time Graviton 2 came out, I was already a fan and trying to get all my clients to use it. By the time Graviton 3 came out, I was like, this is a no-brainer. I default with this. This would be what I always start with, unless I just can't. Like, maybe I've got some wicked old software that I don't compile. I didn't get to compile, and I have to compile it for Intel. But anyway, I just want to set the stage for everyone before we keep getting into this. It's like, this is not only pretty new, so I don't blame anyone for not knowing about it or using it, but also I feel like it's a really big deal. And I feel like for people that are in the cloud, and I checked, turns out everyone's following AWS's lead here, and all the other clouds are either have it or just announced it, or are there's on the list of to-dos for the future. I was actually finding out that DigitalOcean doesn't have anything yet, but they're probably got some people that are like, how do we do this? Everyone else is doing it now. So anyway, sorry, back to the show. I just wanted to get all that out there.
All good. And you're right. I know that in each release of a new Graviton series, we have presentations at reInvent that go from like what the improvement is from the previous generation. But I don't know if we have anything that goes from like Graviton, pre-Graviton to
one.
Like,
yeah.
But each jump has been, multi-10 percentage digit improvements, whether it's performance or cost or power consumption. And you add those up, year over year. And if you start to adopt if you move your workloads over to Graviton and start adopting ARM, then you're on that series of improvements, right? Like, it's the same thing. If you've transferred your application to being on the Apple M series chips, like, you just then now get every subsequent performance enhancement going forward. So it's not like a one time, it's not just one time. Like, if you then move to the next series in that family, you can just adopt that. You just get those cost savings or performance enhancements with lower friction. But speaking of that friction, I think you're right. Like, I would be interested in that answer to that question too. Like, why are folks not adopting ARM? And this is a great way for us to get to containers, right? We are focused on containers, and we haven't even mentioned anything to do with containers. So
containers, we said containers. Okay.
Yeah. How do containers fit into this Graviton?
Oh, wait, before the container question real quick, I want to answer a question just saying, what can't be run on Graviton that needs to be on x86 based EC2? Michael, you got any thoughts on that?
Yeah, so probably the biggest group of workloads that cannot be run today on Graviton are Windows-based workloads. And that's because to date, Microsoft has not made a version of Windows Server available that runs on ARM64 to us. And although Windows has been able to run on alternative processors for a very long time, the ecosystem has coalesced around Intel CPUs. And so there's the lion's share of software that runs on Windows today is all Intel. And a lot of it, and also the closed source ecosystem for Windows is much, much bigger than it is on, say, Linux. And so even if Microsoft made Windows Server available on Graviton today, or whether it be in AWS or in Azure or any place else, you could probably run and build .NET apps for it, or run IIS-based web services on it. But for a lot of our customers, they use Windows because they are getting their software off the shelf or from some ISV that's been compiled for x86. And so it'd take a while, I think, for the Windows ecosystem to catch up to the Linux ecosystem.
Which has been true on Linux. Like it did, we still have little pockets today of open source that's not automatically precompiled to ARM. And so that stuff does exist. I was actually going to say, I didn't think about the Windows side. It's a really good point. I was going to say my experience has been, it's always compilation. I don't have access to the source code, and this thing I'm using is only x86 64 built. And I didn't think about the Windows side, but I have customers using .NET that they're using .NET Core, but maybe it's not .NET, maybe it's something like PHP. I just remember it's an old Microsoft SQL driver they're using, and it's only, and I'm pretty sure, and they're running on Linux, but it's only it's an apt install, but the apt package or whatever it was, a dependency package manager only had the Intel built, essentially the Intel compatible built, and they weren't a sophisticated enough team to go find that source, repackage, rebuild it, repackage it, put it on their server. That was like, to them, that was, at the time, it was like, well, we can't. And there was a newer version of the driver that they could have updated to, but that's a feature request, so they were like 6 months to a year before they could even test on it. So we got OS compatibility, compilation, or not having access to the source code to build. Is there anything else? That's the thing, right? Is like we're on Graviton 3 and 4 now, so these things are so big and so fast that any of the old arguments of like, well, I need more CPUs, or I don't have enough RAM yet, or my instances are faster networking. Like, I feel like have all those reasons gone away in terms of the performance, like general CPU networking performance and storage and all that?
Well, the interesting thing is that, I was talking about Nitro earlier, and our Nitro technology is, because it's in a card that plugs into a bus socket, and the buses are the same for both of our instance families. The same technology, actually, the same Nitro cards plug into both our x86-based instances and our Graviton-based instances. Again, another advantage of offloading that onto Nitro is that it allows us to actually experiment or diversify our compute while maintaining the same great performance in terms of storage virtualization and network virtualization that we could before. And with every new instance family or instance family and generation that we release, sometimes they'll come with our newest generation of Nitro, and certainly with Graviton we've done the same. So there's, in terms of IOPS, in terms of storage throughput, EBS, in terms of onboard SSDs for the storage optimized instances or instances that have a little D in the suffix, it's all the same technology. And so the very vast multi-gigabit up to 100 gigabit networking equally on Graviton, and same storage and same features of Nitro, such as onboard encryption, hardware-based root of trust, and so on, all available for Graviton with no loss of performance.
Nice.
And those are percentages that add up. So if you started adopting Graviton early days, I mean, you have like a pretty nice curve of cost reduction and performance increase since then. Mm-hmm. So what's one, this is alluding to containers, but what's one way to get folks to more easily move their workload to a Graviton instance, Michael?
Yeah, so that's the cool thing about a lot of modern workloads. Most of the customers that I speak to, and I'm willing to bet that a lot of our audience here in the show today, probably don't write their software in C or C++, where the architecture really matters because you're actually compiling source code to some sort of executable code that you then run, and that executable code is architecture independent. Most of my customers, and I'm willing to bet most of the audience here, is probably running software that is written in a higher level language, for example, Java or C# on .NET, or they're running applications in JavaScript, or they're running Flask apps in Python, or perhaps they're building in Go or Rust or PHP, Ruby on Rails, for example. With the exception of Go and Rust, Java and all the scripting languages, there's usually often not much lift in terms of things you have to do to make your application run on Graviton, because the interpreters and the runtimes, the Python interpreter, the Java runtime, .NET runtime, they're already available for Graviton. And you can get them just as easily as you can for x86. For example, in the containers world, if you do a Docker pull of a Java runtime, and I actually talk to Docker on a pretty regular basis. And last I spoke with them, 60% of the top 1,000 Docker images that are available on Docker Hub are already available for ARM64 as well as x86. And if you're lucky enough to have let's say a MacBook Pro today with Apple Silicon, that uses the ARM64 instruction set as well. And so if you do a Docker pull of a base image like Nginx or Java or Python, it's going to pull the ARM64 version. And you're actually able to do this through a technology that's called image manifests. I won't get too far into the weeds with that. Docker images for a very long time now have had multi-architecture support in the registries and in the ecosystem for a really long time. And the experience of launching a Graviton instance on AWS is as simple as it is for launching one for x86. Yeah. So if, for example, I go here to the EC2 console, and let me just zoom in a little bit because I know many of you are on mobile devices. But if I go here and I do launch an instance, and I just want to give it a name, I'll just say my web server for the prompt here. All I have to do is when I scroll down to choose, let's say I want to use Ubuntu, all I have to do is choose a different architecture. And when I do that, the instances below will change to the compatible EC2 instances that run on Graviton. And if I scroll down, you can see we have a lot of them, right? The full constellation of compute optimized, memory optimized, and storage optimized instances. So 6GD are all the ones that have 6 in the number. They're all Graviton 2, 7 in the number, Graviton 3, and X are double the memory. So that's 16 gigabytes per vCPU instead of 8 gigabytes per CPU. And then Graviton 4 is coming soon. We'll see that later on this year with R8G. Again, R8G is a whopper. It's up to 192 vCPUs and up to 1.5 terabytes of memory. Yeah, it's big. So the LARP experience is exactly the same. If I'm going to switch over here to my Kubernetes cluster, I've created a multi-architecture demo EKS cluster. And in the compute tab, I've created a couple of node groups. I've created a core node group, which is based on Graviton. I've created a couple of application node groups, one based on x86 instances, the other based on Graviton instances. And, I'll show you that, in fact, a typical Java-based application in many cases needs no recompilation at all. You can simply build a multi-architecture image, publish it, and run it. And, if you guys like, I'd be happy to jump in and do a little bit of that.
Yeah, let's see it.
If you're not familiar with building your applications in Docker images for multi-platform, Docker's got a guide on it. It's basically a couple of flags. If you take any of my courses, if all of my examples on GitHub, I have all of those multi-platform. Largely was pushed by the request of my students to actually want to run a lot of our courses on Raspberry Pis. So I had to do that years even before Apple had Apple Silicon available. So to do this, there is that prerequisite step, right? You have your Intel compiled applications aren't just going to magically run here. I was going to mention QEMU for those that are a little savvy. That is a feature that allows you to emulate one platform on another platform. It does come built into Docker Desktop, so people sometimes aren't even aware of that level of magic happening if they're especially on the Apple Silicons early on, when we had the M1s in 2020 and 2021, where it would just run MySQL, but you didn't realize it was actually running through emulation. It wasn't technically running it. So if you're confused about all that, put it in the comments below, and I'll get you all the resources for that, because I have tons of stuff. But we're not going to cover that. Well, we don't have time really to cover that today as Michael's getting into this demo. But let's just assume you have that, right?
Oh, and as a matter of fact, I'm doing this here on my MacBook Pro with just Docker Desktop here, which you can see up here. I'm using
awesome
Docker Desktop for this. So I am here in my terminal, and I've downloaded and forked a copy of a Java demo app called Spring Pet Clinic, which is, it's sort of the mother of all Java demos. Been around a while, but it's great. I think it's a good demo to use for showing how easy it is to take a Java app and run it on either x86 or Graviton. with ease. And if you can see here's my source code base. I've got my source here, and I went ahead and I built a custom Docker file. So let me show you the contents of my Docker file. The Docker file that I built is really, really quite small. It starts with a base image that is my Java runtime. In this case, I'm using the Amazon Corretto Java runtime. I happen to be using version 21. We always recommend that customers use the latest stable version, long-term supported version of Java that is available because it'll provide the best performance for Graviton. But you can use Java 17 or even all the way back to Java 8 is supported. We have customers running on Java 8, 11, 17, and then a few leading edge customers are running on Java 21. My second line, I'm just making a directory inside my container image, just called app. And I went ahead and I built the jar file using Maven, which is the standard tool for both Maven and Gradle are common build tools. They're like Make for Java, effectively.
Right.
And at the end of the process, I ended up with this snapshot, this Spring Pet Clinic 3.2.0. I just simply copy that jar file into the app directory, expose a port, and then my entry point's really simple. I just run Java and point to the jar. And when I run that, it'll go ahead and launch my server. So what I'm going to do here is I'm actually going to, and you'll notice here, there's nothing architecture specific in here. I'm just simply copying a pre-built jar and running it in my container image.
I'm glad you pointed that out because it doesn't say in there ARM64 anything. So
no, there's nothing in there. Now, there may be cases where more complex Docker files are needed. Best practice suggests that you really should be, building the jar itself in a container. But for the purpose of this demo, I just built it here on my Mac. And you'll see that even though I built it on my Mac, it also runs on x86, even though my Mac is Apple Silicon. And that's the power. One of the cool things about Java is that it produces architecture independent code in the class files that are then packaged into the jar files. All right, so what I'm going to do now is I'm actually going to build my Docker image. And this is where the magic is done with Docker BuildX. Docker BuildX gives you a very convenient way to build a Docker image for multiple CPU architectures, regardless of what kind of developer environment you're in. Mm-hmm. On my MacBook Pro, I can say I want it for Linux ARM64 and Linux AMD64, which is x86. And then I'm going to tag it with the location of my ECR repository. Amazon ECR, if you're not familiar, is AWS's managed Docker image repository. It also supports Helm charts as well. It's a OCI compliant image registry. And I'm going to go ahead and push it at the same time. So this doesn't look very different from your typical Docker build invocation, but it is using Docker BuildX, and I'm adding platform forward to target, and it will go ahead and push the image to my registry. So I also want to check on my registry over here, and you'll see here I've created a pet clinic registry that currently has no images in it at all. So this will be a one-step process. So let me go back to my terminal, and I'll go ahead and run this. So we went ahead and built and pushed the images to our repository.
Yeah.
So if I do a refresh now, you'll see here that I have a latest image tag, and then I have a number of different images that are untagged. They are important and part of the composite image. I want to actually show you a little bit about, curious viewers, what happens under the hood when you produce a multi-architecture image. So there's a cool command called docker manifest inspect. And what that does is you give it a pointer to a repository and tag, and it will show you the contents of the JSON file that this pointer actually points you to. It doesn't actually point you to an image. It points you to a JSON document called a manifest. And you can see here that the manifest is actually a list of pointers to other manifests. It actually looks like a tree under the hood. And you can see here that I have two manifests for my layers. One is for ARM64 and one is for AMD64. This is the magic that allows a container runtime to select the appropriate layers that it's going to download based on whatever the CPU architecture and operating system is. So the Graviton instance is going to look at ARM64 and pull these layers. On an x86 instance, it's going to match the architecture as AMD64, and it's going to pull those layers. And that's what we just went ahead and produced, all of those layers and this manifest in that one BuildX step.
Nice.
Yeah. So you can, as I said before, you can see now that I've got my images here in my repository, and I can then go to my deployment directly. And actually, I want to show you that I have the nodes available for my Kubernetes cluster. I've created a little alias called KGN, which is kubectl get nodes. And this will show you, and I've sorted by node group to make this easier for people to see, that I've got some core nodes on which I run core DNS, for example. And over here, I've got a couple of empty x86 and empty Graviton nodes for my app. And I've got 3 different YAML spec files in here that correspond to my x86 and Graviton deployments. Just taking a look really quickly at the Graviton deployment, you can see here I've got a deployment here. And in my node selector, I'm using node affinity to deploy the ARM64 to my Graviton node group. I'm going to go ahead and deploy some of these. I'm going to deploy two of these replicas to my Graviton deploy node group. And I'm going to create a service called Pet Clinic Graviton that points to that set of pods. And I do the same thing for x86. The only difference is that I'm targeting the x86 node group and my affinity in my node selector. And I'm simply using a different name for the service and for the deployment.
So what you're doing between these 2 deployments is picking between those 2 node groups, explicitly saying only deploy these pods or create these pods on those specific node groups with those specific architectures backing them.
Yeah, you can see here there are really only a couple of differences between I'm just simply changing it from ARM64 to AMD64 and changing it from Graviton to x86. There's no other significant difference between these 2 YAML files here. All right, so I'm going to go ahead and apply these Clinic Graviton, and I'm going to go ahead and do the same thing for x86. And then if I go ahead and show them, you can see here now that I've got 4 pods and I've got 2 services. And if I actually show what nodes these are being deployed on, so I've got 2 Graviton nodes, 131.166 and 158.7. So if I've done this right, my Graviton node should be running on 131.166 and 158.7. So that's all set. And then 153.89 and 142.61, 142.61, 153.89, they match my x86 nodes. So we're all good in terms of deployment. All right. So now what I can do is I can do something like I can do a port forward to kind of show what it looks like for node group here. So if I do a port forward and I do a service Pet Clinic x86 and I do port 8080, if I open my browser here, I should have a or Pet Clinic. And then what I can do is just go ahead and page through those. Everything looks good. I can add a new owner. I can do, Bart Simpson, 742, delivering Paris, Springfield, right? So that's all good. Oops. I guess that all needs to be, there we go. Add a new pet, Santa's little helper. No one, 26, and it's a dog. All right. So Bart's got his dog here. And if I got that right, I should be able to type in Simpson here. And there he is. Great. Awesome. Now I'm going to go back and I'm going to close this port forwarding and go to my other port forwarding or to my other service. Done the same thing there. And I'll flip back here. And if I did it right, you'll notice here I've got a Graviton instance.
Nice.
Exactly this. Again, same image. Didn't change the image at all. The image is exactly the same in each spec. So if I do a grep image, Pet Clinic, you'll see that the image is exactly the same. No difference between them. Running on both. And if I do find owners and I do Simpson, there he is, Bart Simpson, because it's using the same database. Yeah.
That's
awesome. I can go one step further as well and apply a multi-architecture service that creates a service that points to both deployments.
And then switches between the 2?
Yeah, and we'll load balance between them. So if I get my ingress here, you can see I've created a Pet Clinic. It'll take a couple of minutes for the load balancer to initialize. But when I do, you'll actually see as I flip through the pages that I'm going seamlessly between x86 and Graviton with no loss in performance and with no loss in data fidelity.
Do you find that most K8's tooling offers multiple platform images when you see folks move to Graviton, how often do they end up having to keep a couple of ARM or AMD 64 machines around for some third-party dependencies? Yeah, I'm curious if you have any experience with that.
Great question. So the ecosystem for multi-architecture for Kubernetes is growing more and more every day. I would say the vast majority today of Kubernetes add-ons and controllers and admission, whether it be admission controllers or whether it be operators, for example, Spark operator if you're running data-centric workloads, or Kafka operator, or the vast majority of ingresses like Nginx all work for Graviton out of the box. The one that was a bit of a laggard for a while until last year was Istio. But Istio is a version, I think 1.17, is also available for ARM64. So the most popular by far add-ons for Kubernetes, Cilium as well, are all available for Graviton. So that's less of a concern these days. Now, that said, there are some workloads that run better on x86 still that need a GPU. I mean, for example, if you're doing training workloads, you still probably want a GPU today. And so customers, I love Graviton, don't get me wrong, but we offer 750 EC2 instance types, the majority of which today are still x86 based. And if a customer finds that they need to run their workload on x86 still today, that's okay by us, right? We're going to keep making Graviton better and better all the time, but we also recognize that there's still room. It's a big world out there, and there's still room for applications that need to run on x86. And the great thing, as I demonstrated here about Kubernetes, is that you can have your cake and eat it too. You can have Graviton nodes for workloads that run better in terms of price performance on Graviton. You can have x86 nodes in there for workloads that are still x86 dependent or have accelerator performance on x86. And that's fine. And you can, as Graviton's evolves, you can then add more of that to the cluster and migrate your workloads from x86 to save money and be more sustainable. So it's a win-win for everybody as far as I'm concerned.
Yeah, I was going to throw in my own anecdotal evidence of over the last 4 or 5 years of trying to get all my examples and course code and some of my customers onto it. I'd say 80 to 90% of infrastructure, Kubernetes and Docker tooling, I'd say 80, 90% is all pre-built. And if it's not that way and it's open source, there's probably a GitHub issue that says, please add ARM support. And there's like 1,000 thumbs up or something, right? And so there might be technical hurdles. I'm glad you actually mentioned the GPU thing because I wanted to make sure we got that into the audio of are there GPU options for ARM and what does that look like? Is that something that's planned? Do we even know if NVIDIA is building that out? Like what, do you know?
Yeah, so I can speak to what we offer today, which is G5G instances. G5G are a combination of both Graviton-based CPU and NVIDIA-based GPU based on the NVIDIA Tesla platform. We also know, now granted, this is not about AWS, but we also know that NVIDIA has announced Grace Hopper platform, which is also a combination of NVIDIA GPU and ARM64 CPU. So it is definitely not just AWS who is investing in ARM64 at scale today.
Right.
As you mentioned earlier, every major cloud platform provider today either has announced or has ARM64 technology available for customers in production today. And I shouldn't forget to say that there's a constellation of AWS services available today, managed services like RDS, OpenSearch, Neptune, managed MSK, the managed service for Kafka, MemoryDB, Elasticache, many of which are defaulting to Graviton today. So if you go and create a new RDS or Elasticache cluster today, it will actually default to Graviton whenever possible. And that's an easy way for customers to adopt Graviton without even having to deploy any software at all.
That's similar to the question, can some services like EKS, ECS, RDS use Graviton?
Mm-hmm.
Yeah, so this is an ECS cluster that actually has Graviton instances, M6G, M7G, and C7G, and M6I, which is Intel, all in the same cluster. ECS, you can add any kind of EC2 instance to the cluster. And with ECS, if you're using serverless compute, Fargate, you can choose the ARM64 architecture and run serverless containers on Graviton with your ECS cluster.
Very cool. There was another question I'm going to throw in here real quick. Can I build ARM images with x86 machines and vice versa? I threw in some of my own experiences of, yes, there's multiple ways. I think it's language specific and tooling specific. For if you're in Go, for example, it's just it's a part of the Go build command, which platform you're building for. And like .NET, I believe, they actually prefer that you build on x86 for whatever the platform is going to be. And then, so you don't actually want to build on ARM. I think there's actually, if I remember correctly, I may be wrong on this, but I was testing out a .NET project and it seemed like it really wanted me to build on Intel and then just define what I'm building for, and it would compile it properly. I've also used QEMU, which can be very slow, particularly when you have to like build C stuff. It can be very slow to use emulation. I do that on GitHub Actions because for the longest time, we didn't have anything but x86 64 for GitHub Actions. So I had to build that there. I don't know if you have, Michael, any other experiences or thoughts on that?
I think it depends on the level of maturity. So we see customers start with BuildX, which is what I did here, where I just added the x86 and ARM64 platforms to the platforms list. And it does use, if you're using Docker Desktop, for example, or if you're using Docker Engine on Linux, it does use QEMU under the hood. And for short builds, it's not usually a problem. I mean, it's a very convenient way to do it. But as you said, when you start to build very large bespoke images, and perhaps there's a lot of compilation as part of the build process, emulation can really add up in terms of time. And if you're the type of team that's producing, 20, 30 builds an hour, you probably don't want to wait, 5-10 minutes or even longer for an emulated build to be produced while the non-emulated one takes a minute. As those builds become more and more complex, that difference in time becomes quite dramatic. And so for mature customers, we recommend using a build pipeline. So GitLab, GitHub Actions, GitLab, AWS Code Commit, Circle CI, Travis CI. There's a whole constellation of CI/CD providers out there. Even Jenkins, we still have a lot of customers using Jenkins, and we recommend that they use native build runners in that as they mature. So you'll have x86 build runners, you'll have ARM64 build runners, and you'll produce an architecture-specific image on each one. And then they'll use that Docker manifest command that I showed earlier. Not only can it inspect images, that can also stitch them together into a single multi-arch image that then you can reference in your pod spec or in your ECS task definition, and then have the right one automatically pulled that matches the architecture. And if you're using native build runners, end up getting you the speed back that you might have lost with an emulated build.
Right.
We covered an immense amount of ground here in 1 hour. What were you going to go to next, Michael?
Oh, I was going to show you I went ahead and did that to Ingress. You should be able to see here that I'm going through an application load balancer Ingress to a multi-architecture deployment. And you will flip through the pages that the architecture changes too. And if I find my owner here, Bart, you're showing up seeing that the page is ending up the request is being directed to Graviton and x86 alternately. So you can see here when you're migrating that it's completely seamless.
Yeah, that's why I've been encouraging people. This is a great example, by the way, of the flexibility of containers, with just maybe a few tweaks to make sure your Docker images or your Docker files rather can be built multi-platform. Because if you haven't tested it, it's kind of a crapshoot. It totally depends on your project, your dependencies, and all that stuff, whether or not it just works when you build it. But like that extra little work now, it just shows how much it pays off in your flexibility in the future. I've been trying to get a lot of my clients, and I'm reasonably successful, to just get them, even if it's just the argument of for the Mac people, because a lot of teams, they got Mac and Windows people and Linux desktop people all in the same team. And for the Mac people to just, because they're on M1s probably, or one of the M series, and they're already running ARM, to just build it for them with this secret little, like the DevOps team that we work with, a secret plan that we're going to be able to enable Graviton infrastructure, an ARM infrastructure on the server end. But our initial reasoning was to make it faster for developers locally on Macs. And that's actually, that strategy has worked, because it's not, you can't guarantee that everything's going to run magically and better until you actually test it. So we didn't want to oversell it and say, it's going to drop your AWS bill. It's going to make everything faster. Like we kind of knew some of those things were probably going to happen, but we didn't. So we would come in and say, well, we're just going to make it faster for the DevOps or for the developers on their local machines. And then we did all the work with the images. And now, like you're saying, there's probably, if any change, it's only targeting a different Kubernetes node pool. There's very little changes usually on the deployment side to get these things to run on just try a different instance size. Basically, that's what you're doing. You're just picking a different instance. And I love how that, if you do the work now, I feel like it's, this or whatever you come up with next, like ARM 9, I think is still backwards compatible to ARM 64. So that's not going to be an issue, but like there might be another chip. We might be going back to Spark. Who knows? But having this flexibility in the multi-platform part, I think is the real hard part for a lot of the teams I work with. Are there any other pro tips or tips you have for people getting started? Like, are there hurdles you see customers maybe constantly hitting that they can plan for now? Any sort of tips or recommendations you have for anyone?
Yeah, I would say number one is relax. It's actually really easy to adopt Graviton. And, I'm hoping that the folks in here are just as passionate about DevOps as I am. And DevOps means, DevOps involves building things yourself, right? Building CI/CD pipelines, operating. And for those of you who are working on platform teams, understanding what compute capacity looks like and how to arrange for it and how to operate container orchestrators. And I personally encourage you all to be excited about adopting Graviton because not only is it a new avenue for you to explore in your journey through your career, you're going to be doing things like building, more complex pipelines that are able to do things like parallel builds and parallel deploys. You really get to exercise your skills around managing diverse compute, which you're probably even doing already with x86, but just adding a little extra flavor in the mix with alternate architectures. And then the great thing is that the benefit at the end of the day is that you get to run your workloads for less and more sustainably. And that really opens the door for you to invest in your own growth. And that's the way that I look at Graviton today, is a way to invest not only in cost and sustainability, but your own growth as well.
Very cool. I can't think of a better way to end this discussion than that. So
I do feel like we have an excellent to like get started. We started and ended with the same thing. You should check this out. If you're not checking it out, go check it out. I want to thank Michael, by the way. Thank you so much for being here. Yes. It's wonderful how that demo looks so simple. I'm sure there was a lot of work on the back end just to get everything right with Pet Shop and all that. But it just kind of, I love how it shows the simplicity of if you do the initial steps now, if you focus on multi-platform image and all that it isn't that much work to get started. So thank you for being here. And for those of you out there, please throw in the comments, jump into the Discord server if you want to talk about ARM. I will talk about it nonstop all day, every day. I have multiple repos with examples. Multi-platform building is a little hobby passion of mine. So I'm into it. Let's talk about it. See y'all soon. Thanks for watching, and I'll see you in the next one.